Instead of buying an expensive garage door opener remote, I'm going to make a DIY remote that not only costs less than $10, it's going to automatically open the garage door whenever I return home, but only if the garage isn't already occupied by another car. So I bought this garage door opener for less than $100 as a Black Friday special a couple years ago. It's been pretty solid. It has Aladdin Connect. It has a backup battery in addition to being pretty quiet, but only came with one remote. And I quickly found out that if I wanted to buy another remote, that alone would cost almost half as much as the entire package that I purchased. That included the opener, the backup battery, the wireless remote, and the wired button. And so for a while, my wife and I, we would just swap the remote back and forth between our two different cars, depending on who was parked inside. But of course, that was a hassle, so I wanted a better and cheaper solution. Since I already had Home Assistant set up and connected with Genie's integration so that I can control the garage door over a Wi-Fi connection, I just wired up a button to a Raspberry Pi Pico W and wrote a simple program in MicroPython that would connect to Home Assistant and toggle the door open or close whenever I press the button. I even made it so that whenever I returned home, it would automatically connect and open the door without having to press the button at all. And I added a temperature sensor and a small OLED screen since they're inexpensive as well. And that allows me to see additional information about what's happening in case the connection doesn't work. And finally, this simple dual channel relay lets me power the front and rear dash cams that I have in my car with power from the cigarette lighter whenever the car is on. And then the relay automatically switches the power connection to a power bank that I hook up when the car is off. And since I have a Prius, which has a small 12-volt car battery that's easy to drain, this was an alternative to using a hardwire kit so that the risk of the battery being damaged by fully discharging is significantly less. My wife and I share a single garage parking spot for our two cars, and that means that sometimes my wife will come home before me and park in the garage. But then when I arrive home, the garage door will automatically open because of my Raspberry Pi Pico W connected to the Wi-Fi and sending that open command. So today I'm going to upgrade the system by adding a parking sensor that lets my Pico W know if the garage is already occupied so that it won't try to send that command to open the garage door. And so I already have an ESP32 with a few sensors in the garage, measuring motion with an infrared sensor, the brightness of ambient lighting with a light-dependent resistor, the temperature, humidity, and air pressure with the BME 280 environmental sensor. So what I'm going to do is add an HC SR04 ultrasonic sensor as well to detect whether there is a car in the garage. So an ultrasonic sensor is basically a sonar. The transducer labeled T sends out a pulse of sound. The sound wave bounces off of a surface, and that transducer labeled R then detects the pulse when it returns. By measuring the amount of time that has passed before the return pulse is detected and using the speed of sound in air, the sensor can then calculate the distance to the object. Since the ultrasonic sensor already has male headers on it, what I'm going to do is solder some wires with female connectors on one end to the ESP32. I'm going to need to solder the connections for 3.3 volts, the ground, and any two GPIO pins. After the wires are soldered and the sensor is connected, I can add the ultrasonic sensor to the ESP32 configuration and test that it works. We can see that it makes a distance measurement after booted up, and by default in ESPHome, ultrasonic sensors are set to make measurements once every minute. So I'll just wait for the next measurement. If you're impatient, you can change the update interval property to shorten that amount of time. But before the second measurement, I put a sheet of paper in front of the sensor, and we can see that the measured distance was much lower because we had that paper in front of the sensor. Originally, I was going to put the sensor on the shelf or on the table as it provides the best coverage for the motion sensor, which I use to trigger the light in the garage. But the ultrasonic sensor would frequently time out. This can happen if the surface that the pulse of sound bouncing off of is at an angle. And so then the sound wave bounces away from the sensor and not back towards it where it can be detected by the transducer. Because of that, I settled on mounting the sensor near the garage door opener's motor directly above the parking spot and pointed towards the ground. I made a simple 3D print design for a new case that fit all the existing electronics as well as the new sensor. Stuffed everything inside, made sure to line up all the sensors with the holes in the 3D printed box. And before going out to the garage, I ran one more quick test to make sure that the sensors were positioned correctly and that I didn't accidentally disconnect any of the wires while securing everything inside. With that thing checking out, I attached it to the wood panel with all the sensors pointed downwards. And since the electronics in the 3D printed case are all pretty light, a single small screw was more than enough to hold everything up and keep it from falling. With everything in place, it's time to power on the ESP32 again, check that all the sensors are providing readings. With no car in the spot, I can see that the measured distance, which should be from the sensor to the ground, is about 2.1 meters. With the car in place, what should happen is that the sensor should send the sound wave bounce off the roof of the car and back up. And that distance should be less than 1 meter. So I set up an additional binary sensor through ESPHome that denotes whether the parking spot is occupied. The spot's going to be occupied if the ultrasonic sensor measures a distance of less than 1 meter, and it will be considered open or unoccupied if the distance is greater than 1 meter. Finally, we're going to add to the logic of the DIY garage door remote using the Pico W. There's no reason that it has to be a Raspberry Pi Pico W instead of an ESP32, as both can run MicroPython code. This was actually one of my first microcontroller projects, and the Pico family is what I first had on hand and tried. If I were to do it again, I'd probably use an ESP32 since they can be purchased for even cheaper. Without getting into all of the nitty-gritty details of the code, let me explain the basic logic in the program. So when it first receives power and boots up, the chip is going to scan for Wi-Fi networks and check the basic service set identifier, or BSSID for short. This is basically the MAC address for the Wi-Fi interface on your router or access point, and see if any of them match with the list of BSSIDs from my home. If it does, then it's going to initiate a Wi-Fi connection using the SSID, or the name of the Wi-Fi network, and the password. Why do I do this? It's a good idea if you use a hidden SSID for your network. Many people mistakenly think that hidden SSIDs are more secure. After all, you're hiding your network's name, right? So anyone connecting is going to need to guess both the SSID and the password. That's okay if your connected devices never disconnect and leave from the network. But if it does, then anytime that device scans and finds any network with a hidden SSID, it's going to try to connect to it using the SSID that it knows and the password, since it can't know if the hidden SSID of that new network is the same as the one that it was connected to previously. And so, in other words, a malicious actor could set up a network with a hidden SSID and easily get the credentials of your network by listening to these connection attempts, even if it doesn't know what your network's name is. And checking the BSSIDs provides a small layer of protection, and this also helps even if you don't hide your network name, since if someone sets up a network with the same name, the device won't try to connect to it unless it's actually the same BSSID as the one on your home. Going back to what happens on the remote, if the Pico W connects to the network immediately or within the first couple of minutes, it's going to go into standby mode, listen to the buttons on the GPIO, and if it detects a button press, it will send a message over the Wi-Fi network to Home Assistant to toggle the garage door open or closed. If it doesn't connect to the Wi-Fi network right away, then it assumes that I'm away from home and continues to scan for networks continuously. If and when it does find the home network, it's going to connect and immediately send the signal to open the garage door, since it knows that I'm coming back home from being away. With the parking sensor in place, I'm just going to add one additional step here to connect and read the state of the parking sensor and only open the garage if the parking space is unoccupied. This can be done by connecting to and reading the state from Home Assistant, or it can be done by connecting directly to the ESP32 that controls that sensor. With the code uploaded and tested, I now have a much smarter remote than the standard one, and everything, including the ultrasonic sensor that I added to the garage sensors, cost me less than $10 combined.